Good morning, Mr. Yako. My name is Ekraj, and today I'll be presenting about my high distinction task report. And the study that I have selected is on unstructured data. So that is what I will be presenting about today. A quick reason on why I have selected this particular topic for my research report is because this unit is all about the fundamentals of data management, and unstructured data is one of the fastest growing types of data in the world right now. And I find it really interesting to understand what that was all about, because it was something that we haven't really touched on in this unit. So I went beyond the scope just to find out what it was, because it was really interesting to me. Unstructured data and structured data are two of the three types of possible data types, and the third being semi-structured data. In this presentation, as I previously mentioned, I will be focusing primarily on unstructured data and how the use of this data type is growing as compared to structured data. According to the IDC, which is the International Data Corporation, we are seeing a massive growth in unstructured data. From the graph being displayed, we can clearly see that structured data is only making up for about 20% of this. And another report from Dell Technologies projects that the digital universe will grow up to 40 zettabytes, which is about 40 billion terabytes by the end of 2020. And the majority of that data, as we saw earlier, will be unstructured. So, firstly, I will be talking about structured data. In order to truly understand unstructured data, we will also have to take a look at this first, and only then we can get a clear look at studying unstructured data. Structured data exists in a format that can be created to be captured, stored, organized, and analyzed. And in this unit, this is exactly what we were focusing mostly during this semester. And we were taught to understand structured data and to find a way to extract a particular result with the help of, you guessed it, a relational database management system, such as MySQL. This form of data is neatly organized for effortless access. And a great quote by a guy named Dan Muse, who wrote an article on structured data, also states that structured data may account for only 20% of the data in the world, but its organization and efficiency make it the foundation of big data. With that in mind, we can now proceed with unstructured data. At its simplest, unstructured data is every piece of data that we cannot use or fit into a relational database the way we normally would with structured data. But that does not mean it is raw data that is not entirely usable. Unstructured data is still information, but in many different forms that does not conform to conventional data models, which is why it typically is not a good fit for mainstream relational databases. One of the most common types of unstructured data is text. This unstructured text is created and gathered in multiple forms, including Microsoft Word documents, emails, text from the PowerPoint presentations, survey responses like Google Forms, social media posts, and even call transcripts. And this is all just from one type, which was text. So you can imagine how robust this form can get and how flexible it is. Going back to structured data again, let's take a look at an example of how structured data can look like in a real case scenario. And this should look quite familiar to you. Structured data is all about categorizing quantitative data, and it's the type that we are used to working with in this semester, and what most companies use as well when they are working with data that they need to use almost every day. This means it should be easily readable. Structured data is easy to search and to organize. This is done with the help of a structured query language called SQL, which I will get into more soon. Each table in this example is called an entity. In this case, the figure has 4 entities: product, line item, order, and user. In structured data, these entities can be grouped together to form relations. A relation in this figure is what we can see when an entity has an arrow pointing to another entity. The part where structured data shows that it is very useful is the fact that we can easily query a form of search to link all these tables together to find a specific set of data. For example, we can find out all the customers who live in 99 South Street who bought a specific kind of ice cream. Now that we know that, we can answer the question on how structured data is actually managed in the real world. It can be managed using, as previously said, SQL. I know it is actually pronounced SQL, but that's how my lecturer in Foundation pronounced it as SQL, and I've just been pronouncing it ever since. SQL is a type of programming language that is used to do set operations such as union, intersect, and minus to organize and retrieve information in a relational database with high usage of set theories and relational algebra. In any system that uses SQL, data elements are called attributes and they are categorized into columns, as we previously saw in the graph. SQL was developed by Donald Chamberlain and Raymond Boyce at IBM in the early 1970s, and it was originally called SQL, short for Structured English Query Language. And now that we have sufficient knowledge on structured data, we will now fully begin with our explanation on unstructured data. Unstructured data is still all about storing data, but it does not necessarily have to make sense to the people reading it, or it doesn't have to relate to one another, just as how we have seen in the previous example. Let's take an example of unstructured data, and in comparison, remember what I said earlier about the rules of unstructured data. Unstructured data is not fixed to a single form. For example, in structured data in a DBSM, each value would have to match and fill up its attribute values, or even fill up null, to match the data type it was required. In other words, this form of data does not have to conform to a data model and has no easy identifiable structure. Unstructured data cannot be stored in the form of rows and columns and does not follow semantics or rules and no particular sequence. With reference to the figure shown, we can clearly see that the data value attached to each field accepts various data types, such as strings, integers, and even geocoordinates and arrays. This gives it a high advantage over structured data, such as SQL, as the data is not constrained by a fixed schema. Another major factor is that this data is scalable, which is the key reason why it is adopted by many large companies dealing with big data, which will be touched on later in the presentation. Just a side note, I noticed while editing, you might be wondering what what this is. It's actually a counter of the days left before my flight to KL. And this is how I keep track of what I need to do, like all my past tasks. You can see high distinction task here and your portfolio submission. And these are all the things that I have done already. Okay, back to work. Getting back on track, so now you are wondering, if unstructured data is so unreadable as I said, how can we manage it? A very popular method and application that can be used to store unstructured and even semi-structured data is with NoSQL databases. This is actually what we learned in our final week of data management. And basically, NoSQL is a non-relational DBMS that does not require a fixed schema and is easy to scale. The main purpose of a NoSQL database is for distributed data stores with very large data storage needs. The concept of this database form is very popular among internet giants such as Google, Facebook, and Amazon, who deal with large volumes of data every day. If they were to use a relational database, the system response time can be very slow when dealing with massive volumes of data. NoSQL stands for Not Only SQL and was developed by Karl Strauss in 1998. After reading a bunch of articles, I found that majority of them always stated that there are four major types of these unstructured data systems that are mostly common in the industry. Let's take a look at them. First and foremost, we have document databases. With the use of JSON-like documents, document databases are both natural and flexible for developers to work with. As a class of non-relational or NoSQL database, this document data model has become the most popular alternative to tabular relational databases. This is actually what we learned in week 11's lab when we worked on MongoDB. Secondly, we have key value stores. Key value databases are often considered the simplest of the NoSQL database. Key value databases treat data as a single collection with the key representing an arbitrary string and the value being any form of data type such as a string, integer, or array. Key value stores use much less memory while saving and storing the same amount of data, and in turn, increasing the performance for certain types of workloads. Following that, we have wide column stores, which refers to a category of NoSQL databases that works well for storing enormous amounts of data that can be collected. It can be defined as a multidimensional nested map of maps, where data is stored in a cell of columns and grouped into column families. To visualize how powerful this database can be, one single column in a wide column store database can include information that would take up many rows in a conventional relational DBMS. Last but not least, we have my favorite, graph databases. A graph is composed of two elements, a node and a relationship. In each of these graph databases, each node represents the entity and the relation represents how each of these entities are related, similar to what we have learned in the unit. The real world is interconnected, and the graph database aims to copy those relationships in an intuitive way, and that's what makes this graph database very much different than other database models. It maps more realistically how the human brain maps and processes the world around it. Now we can move on to the million-dollar question. What is the importance of unstructured data and how can we manage it? To answer quickly, majority of the data generated today is unstructured data. And according to an article written by Leslie Boucher, approximately 2.5 quintillion bytes of data are created each day. And it is estimated that 80% of all that data is unstructured. To simply put it, there is a lot of unstructured data out there, and it is growing by the second. A lot of the things labeling to unstructured data consist of things that are just used in the everyday life of a typical consumer like you and I. And a good example to visualize this fast-paced growth is with WhatsApp. According to an article on CNNet, it stated that Facebook, who had recently bought over WhatsApp, said that the total WhatsApp users sent an estimate of 65 billion messages in a day. This is just one aspect, but a very great showcase on the reason why unstructured data is growing exponentially. In my research report, I had used a study that was conducted by a company called Igneous. Igneous is a company based in the United States that delivers unstructured data management as a service solution. Their study, called the 2018 State of Unstructured Data Management Survey, had queried 200 data-centric companies in North America from various industries. The point of this study was to explore unstructured data growth trends, what problems UDM causes, and how the industry is addressing these problems. I have selected this particular study because of its latest relevance and the fact that it addresses my study very well. I have also used a research paper by Adanma Abarendu from Madonna University in Nigeria, which mainly discusses the distribution of these unstructured data. With reference to both studies, Abarendu had stated that a factor of why data volume has grown so exponentially in the past years is because of the explosion of machine-generated data. And in the study by Igneous, it states that due to that factor, it is becoming very easy for a company to manage a petabyte of data, and it's becoming very common, as majority of the data is automatically created every second. From the 200 respondent companies, 82% have said to manage more than 1 billion files and objects, and a massive 59% of the companies are managing more than 10 billion files. Reports have also shown that more than 55% of this unstructured data is machine generated. A director of a company from one of the respondents said, "We are seeing unstructured data grow roughly 50% year over year. But this does not mean a bunch of meaningless data is coming in. This growth could be crucial to determining the company's next move or even a major business decision." In fact, reports have shown that 40% of an organization's value comes directly from their data. This means you could say that data is more valuable than branded inventory. Also, a lot of this unstructured data is user data. If let's say WhatsApp were to just randomly delete a portion of their data, you could wake up to all of your chats missing. Now we can move on to finally discussing the results obtained by the Igneous study. The figure shows the results from the Igneous study when the companies were asked how important the following objectives were in comparison of structured and unstructured data. From the figure, we can clearly state that in structured data, protection was placed first, and in unstructured data, security was the first priority. Although protection and security can seem like very similar words, they govern very different aspects. We need to understand that protection mainly focuses on internal threats of the system, such as controlling who can access the data, while security mostly focuses on external threats from the system. A reason that organizations place such high value on security when it comes to these unstructured data could be because these forms of data could be very personal data of the consumer, and at times not even the company should take a peek of that data, because if it was to be breached, it could be a major violation. Secondly, we can see that accessibility was also a major factor. As previously mentioned, unstructured data does not follow a specific scheme or a normal table. This means that it can get very tricky to locate a specific type of data. The companies were asked what they were struggling with the most when it came to managing unstructured data. And the figure states that the respondents mainly have issues with governance. Data governance is the process of managing the availability, usability, and integrity and security of the data. Without data governance, there can be inconsistencies that will not be resolved, which in return will also affect analysis accuracy in the company. The report also states that organizations are also faring poorly with two important aspects: data insight and accessibility. This is bad, as insights are the main pillars that help company with their decision makings with real data to back up their decisions. Up until this point, we can now understand the power and value of unstructured data in the world. But there is still a major issue when it comes to it. Firstly is the lack of schema and structure. Unstructured data is often raw and unorganized. This makes it very difficult to read and understand. It is possible, however, to convert it into structured data, but that can be very time-consuming and expensive. And due to the flexibility of unstructured data, not all forms of it can be converted into structured data. Secondly, it is unsuited for interconnected data. Unlike relational database models, the entities we will use can somehow relate to one another with the help of primary and foreign keys. With relevance to NoSQL, it is often hard to find a way to relate these entities as they could mean very different things. In conclusion, it's no surprise that this form of data is increasing exponentially. The world is moving into an era of IoT, where everything in our lives, including basic items such as a coffee pot or even a car, is being infused with technologies to get it connected to the internet. And the base of IoT is collecting as much data from the user to get a better understanding of how users and consumers use their products. It is up to the companies to ensure that they are doing everything right to make use of that data, such as with data management and data analysis. With the rise of IoT, we can expect the rise of this form of data to increase even more so. This was very challenging and interesting, I'll give you that. So this was fun, and I really hope you enjoyed this presentation. With that, thank you so much for listening. I'll see you on campus soon.